and place a parent behind him. And then a parent behind that, and so on. And only then does the true scale of the evolutionary process start to become clear. Generation after generation stretch into the past, forming a queue of spectacular proportions. The first of our kind, the modern Homo sapiens, are 100,000 years old, and would be 5,000 generations, or about 3 miles down this line. Earlier species, such as Homo habilis, the first of our ancestors to use tools, are much older, at 2 million years, or nearly 60 miles away. But as we get further and further back in time, the picture starts to become obscured. And until recently, the last known outpost was an animal that lived between 3 and 4 million years ago, or 120 miles into the past. It goes by the tongue-twisting title of Australopithecus afarensis. When the skeleton of this animal was first discovered, it was given a rather more catchy name, Lucy. And the man who found her was Don Johansen.
Here was a specimen that opened up for all of us, but especially me, an exceptional opportunity. An opportunity to describe a new species of human ancestor. Not only was it an associated skeleton, bits of arms associated with bits of legs, a pelvis, part of the rib cage, part of the skull, a complete lower jaw, but it was more than 3 million years old.
At the time, Lucy was both a revelation and a sensation. And to this day, she is perhaps the most famous single skeleton in the world.
She has continued to play a very pivotal role in the profession as a benchmark by which other discoveries are judged.
But Lucy is a mere juvenile compared with the claims being made for Orarin. For if it is 6 million years old, it would at last give us a glimpse into our most distant past.
This is a period of time from which we have 3 or 4 fossils that you could fit into the palm of your hand. And anything that would be found in this time period of 5-6 million years has to be important.
With so much at stake, it's crucial to refine the date of the find. To do this, the team have invited a group of scientists from the University of Shimane in Japan to try to get a more precise figure for the sediments in which Orarin had lain for so long. There are several methods, one of which uses the way the Earth's magnetic field changes over time. First, they measure the precise orientation of a sample using an extremely accurate compass. It is then carefully marked before being taken away for analysis. Inside this rock, tiny magnetic crystals form, and as they do so, they all point in the same direction, in just the same way as the compass being used to mark them. However, every few 100,000 years, the Earth's magnetic poles switch places. South becomes north, and north becomes south. And this causes the crystals in the next layer of stone to form in the opposite direction. Over the millennia, a unique magnetic fingerprint is left behind. And this enables the rock to be dated.